Hey everyone, it's David Bombal back with a very special guest. Quinn, welcome.
Hey David, thanks for having me.
Quinn, it's great to have you on the channel, and this is a really important topic just for everyone who's watching. Quinn, you work for Cisco, is that right?
Yeah, I work in the learning and certifications group, focused on advocacy. So I do a lot of community outreach and bring ideas and feedback and comments about our training, our certifications, our platforms back into our internal teams, as well as advocate for those teams out to our external community.
CCNA has now got Terraform in, and I believe that's the topic you're going to teach us today. It's going to be Terraform for CCNA, but you're also going to give us a demo and perhaps a bit of cloud stuff. Is that right?
Yeah, so I kind of want to break it. There's two different really constituent parts because I really want to talk. I mean, CCNA, especially with the blueprint changes, I know that everyone blueprint changes in general, people tend to get a little worried about. But I want to kind of put people at ease and provide a primer and background for kind of what you would need to know for the CCNA, because in reality, it's really not that much, and we'll touch on that in a little bit. But then above and beyond that, I want to also show kind of the power of Terraform and really what I use Terraform for. I wouldn't necessarily say in a daily use, but when I do presentations and demonstrations for folks that involve technologies that need to be stood up in a very repetitive way, I use Terraform for just about everything related to that, especially if it's cloud related. So I want to kind of demonstrate how we can use Terraform to stand up some infrastructure inside of a cloud provider as well, just to kind of close the loop on all of that.
So for everyone watching, before we continue, I have to say that this video is sponsored by Cisco. Really want to thank them for sponsoring this video and supporting my channel, and also making their experts like Quinn available to teach us this stuff. So Quinn, it's great to have you here. And just for everyone watching again, if you are only interested in the CCNA portion, then jump to this timestamp. There are two slides that Quinn's going to cover that are really important, so jump to this timestamp. Or if you're only interested in the lab, like the demo, then jump to this timestamp in the video. So if you don't want to see the slides, you just want to see a demo, then go to this timestamp. That's fantastic. So I'm going to keep quiet and let you take it away. Teach us, Quinn. Terraform, it seems scary for people who are new to it, so perhaps you can, put us at ease and, show us actually how it works.
Yeah, absolutely. So what I'd like to always start with, and when you mention the CCNA is whenever I'm studying for an exam or an exam update comes out, I always go to the exam topics. This used to be called the exam blueprint for a given test. And so when we look at the CCNA exam topics that are here on the screen, we see that there's 6 different domains, and each domain has a percentage kind of weight. So in an ideal situation, you'll see about 10 to 15% of the questions come out of each of those domains, depending on the weight there. Some of them for like IP connectivity are higher, just because that's kind of the foundation of the CCNA. But the Terraform specific pieces really fall into the automation and programmability. So that domain is only worth 10%. And then the actual topic item that covers Terraform is the 6.6, recognizing the capabilities of configuration management mechanisms such as Ansible and Terraform. So if we think about an idealized 100 question test, right? 10% of those questions are going to fall in automation, which kind of aligns to the sloping triangles. The CCNA is very network heavy with a little bit of automation versus something like the Dev Associate, which is mostly automation and a little bit of network. So of those 100 questions, roughly 10 would be automation related, and only one of those items deals with Terraform. So we're looking at maybe like 1 to 2 questions, depending on how that breaks out. So realistically, the level of depth for Terraform in general for the CCNA isn't overwhelming. So I want to put everyone at ease for that. What are things that you will be needed to know? And I'll get to some explanation and slides and background about what makes Terraform unique. But kind of just to set the stage, if you've been studying for your CCNA, you've been putting the time and effort, you have something like Cisco Modeling Labs where you've been doing the labbing, you've been looking at OSPF and switching and trunking and ether channels and the wireless LAN controllers and all those pieces behind it. All of that study is still valid. You don't have to throw it away and learn how to program everything with Terraform. So just to put everyone at ease there, it's a small component of that.
I think that's the worry, right? Because this change comes out and everyone thinks, wow, the sky's falling.
The sky is falling! The sky is falling!
I got to know a whole bunch of stuff, but I'm really glad that you summed it up like that.
Yeah, and it's and realistically, like I said, and I'll just jump over to the slides right now and kind of talk about. I don't want to make this too slide heavy and too boring. So if things aren't really clear, I definitely want to make sure I answer them. But kind of getting into kind of what Terraform is, so we can kind of get that background situated. It was developed by HashiCorp in 2014. And it was really meant to be a full infrastructure as code management tool for data centers. Naturally, it kind of tended towards the cloud, and we'll touch on why that is in a little bit. But it was meant really for that cloud infrastructure, or that composable infrastructure that modern day data centers were looking to kind of emulate in their cloud environments, because they wanted something that was fast, flexible, and fully declarative. And we'll touch on what that means in a bit. The reason that I say it was naturally tending towards the cloud is that Terraform is completely written in Go, so the language of Kubernetes, and Google was the original kind of inception behind it. Go natively has a lot of really cool features behind it. It's strongly typed. It's compiled. So if you're familiar with like C or C++, where you had to do the compilation and you created this binary object that you would then execute. So it's a compiled language, and it's very fast and very efficient at what it does. The challenge with that is that Go does not natively have an SSH library built into it.
Yeah.
There are some different projects that have gone on. I know Carl Montanari, who used to be at Twitch and I think now is at Nokia, wrote Scrapply Go. So his real popular network automation kind of toolkit, kind of like a NetMiko thing, he originally wrote in Python. He ported that over to Go. So there are some things that support SSH, but it's not natively in the main Go source. So everything that you interact with Terraform has to have a REST API northbound on top of it in order to interact, or to have Terraform interact and configure that infrastructure. So when people ask me, can we use Terraform in order to configure like our Cisco routers and switches and things like that? The answer is really no, because they don't have a native REST API on top of them. There are some projects that we've created around using RESTconf with Terraform, but it's not like it's a universal platform for everything. So most of the things that you'll be interacting with Terraform are either controller based or cloud based. So all of the cloud providers, Azure, Google, AWS, Oracle, they all have providers. From a Cisco portfolio perspective, our controllers like ACI, the network orchestrator, NDO, then Nexus Dashboard Fabric Controller, NDFC, which used to be called DCNM, things like the SD-WAN controllers, platforms like that are natively REST API northbound, or what you'd use Terraform to interact with. And finally, the last thing that I want to touch on is Terraform is fully declarative, and I'll kind of describe the differences of what that means in comparison to Ansible. But what the biggest takeaway for that is, when I write something, when I create a configuration that I want to apply to, say, a cloud provider, the best way to kind of explain fully declarative configuration management and infrastructure provisioning is the example I like to use for network engineers is applying a VRF to an interface. Yeah. Ordinarily, if I apply a VRF to an interface, I have to configure the VRF and then configure the IP address before. I configure the IP address after the VRF. Otherwise, if I configure the IP address and then the VRF, the IP address is removed. So that's a very procedural set of commands that I have to run in a certain order to get the right outcome. A declarative-based automation really only focuses on the end state. So the way that a Terraform provider, which is kind of the set of instructions or tells Terraform how to interact with a given cloud provider or controller, there's what's known as a redundancy, a cyclical dependency graph map that is built as part of the Terraform process. And that's really just a fancy way of saying it knows ahead of time which things depend on what other pieces. And so it doesn't matter if I write something that is done last at the very top of my Terraform plan, or it's at the very end. Terraform will sort that out automatically for me. So I'm not necessarily worried about, I have to apply things in this order, and this order, and this order. I can just focus on, here's what I want my end state to look like, and Terraform will configure it automatically for me, based on the knowledge of the cloud provider, based on the provider, and based on how Terraform was written with that the dependency map graph that is created. And you can query that, the graph that gets developed. I don't know if we'll have time here for that, but it is possible to use the Terraform graph command to output, and you kind of get this nice pictorial representation of the order that things were applied based on that provider and Terraform's knowledge of how to interact with that cloud resource.
That's great. So, I mean, just to bring it to CCNA for people who perhaps don't know what a VRF is. In CCNA, if you configure an IP address on a sub-interface, like on a router on a stick, right? You've also got to set the encapsulation, and then you put the IP address on. So it's the same kind of concept in Ansible. Is that correct?
Yeah. So Ansible is very procedural,
Yeah.
and you can apply that to a variety of things. Like I can't configure OSPF on an interface before I activate the OSPF process. So pick your poison there. Those are procedural things, and Ansible is procedural because if I put something in the wrong order, you'll get this cryptic failure error message, and then you've got to figure, oh yeah, I did this on the wrong order because it's looking for this piece that isn't necessarily there.
But with Terraform, the advantage is you don't have to do that. It's clever enough to know the order, et cetera, et cetera.
Correct.
Great.
Yes.
That's great.
Which is easy for me because I'm not a big process person. I just say I want this stuff and go and develop, and it works automatically most of the time.
That's great.
So within Terraform, this is kind of the life cycle or workflow that you interact with. Sometimes there, I didn't add all the error bars and, I've got to fix this or fix that. But generally what happens is you're going to write or create your HCL file. And the HCL is the HashiCorp configuration language. It is the domain specific language that Terraform uses. So that would be like, YAML is for Ansible.
Yeah.
So I build that configuration in HCL, and then I'm going to perform a Terraform init and a Terraform plan. And what that does, and one of the things I didn't talk about earlier is Terraform is actually state driven as well. So Terraform keeps copies of the state of the device or the cloud provider or whatever you've configured as you go through these iterations. So Terraform plan says, let's look at my current state, if I have any, and what changes I'm going to be making. And let's rectify the two of what I need to do in order to get from A to B. Now, the caveat to that is that Terraform generally works on the principle of immutable infrastructure. I create something, and if I need to change it, I destroy it and then recreate it so I have a fresh copy. That's different than Ansible, which does configuration management, which is doing that drift from A to B. Terraform will destroy A and create B. So that's why it has to keep that state in sync, because it's constantly tracking what have I done in this project in order to know how I get from A to B, or in this case, how I need to destroy A in order to create B. So I go through that Terraform plan, and it will create all of these files and give me this nice output of the things that needs to change. There'll be some nice color coding if you're familiar with git diff or just diff using the diff command in general. You've got pluses and minuses to say, here's what we're going to be creating, here's what we're going to be destroying, and it gets a nice output for you in your command line window. And then you say, okay, that's what I want to do, and it says if you want to apply, do Terraform apply. And so there we'll do a Terraform apply, and that actually sends that configuration that's in that HCL file up to the resource that you want to configure using those APIs and the configuration items that you've passed along, and it will create that thing for you. Obviously, it doesn't do it instantly because it has to work with those APIs and like in the cloud in AWS or Azure, things have to build and provision and things like that. So, so there will be some waiting. It gives you a nice little timer, and it keeps tracking to say, yes, we're still working. And then when it's done, you have your outputs and you have your infrastructure all provisioned.
That's great.
The other thing that separates Terraform from Ansible is this last piece, and that's the Terraform destroy. So like I said, where, Terraform manages the state, or it keeps track of the state of what we've configured. Because it tracks that state, I get the reverse action. I get the ability to yank that configuration out for free, in quotes there, just by writing something that would create that infrastructure. So if we create that analogy back to Ansible, in Ansible, if I want to remove something, I have to do the equivalent of a no command to remove it. And I have to put that in my Ansible playbook. Terraform, it doesn't matter. I've created what I want my infrastructure to look like, and I can go forward and apply that. And then by invoking the Terraform destroy command, I can remove that infrastructure just as easily as I've created it.
Nice.
So I don't have to worry about how I remove it. It's there just by me writing that HCL file.
That's great.
And that is naturally, well, not naturally, but it's one of the reasons why I love using Terraform for cloudy type infrastructure, because not that I have been guilty of having a cloud overage somewhere because I've left an EC2 instance running or something like that. But in the event that I did, if I provision my infrastructure using Terraform, as soon as I'm done with it, I can just do a Terraform destroy. I remove that, and there's no additional charges that come out of that. So I can be, I don't have to worry about, I have this load balancer, I had these IP addresses or these security groups that are still running. I don't have to worry about cleaning all that out from the ClickOps UI. It's all done by just using the Terraform destroy action.
Yes, you're not going to be bankrupt because you forgot about something running forever.
Yeah. I mean, fool me once. I set up cost limits and alerts, but it definitely helps explaining that the cloud bill, because it's not going to be. There's no overages there. Shouldn't be.
Brilliant.
One of the things that folks have probably the hardest time with is, especially new to programming, new to infrastructure automation in general, is just the HCL language itself, because naturally, I think that most folks like YAML. It's white space. There's indents. Things look really easy. There's not a lot of scary brackets and dots and things like that. It looks really, really easy on the eye. But once you get the basics of HCL, it's fairly easy to navigate in. It's really composed of two things. It's arguments and blocks. Arguments assign, just like we would use a static variable assignment in a programming language with an equal sign. So everything I've highlighted there in the kind of the off yellow goldenrod color is an argument. So in this case, this is for an ACI controller, but in order to connect to that ACI controller, I have to have the username, the password, and the location, the IP address of that, or URL of that controller. So all I'm doing is have variables called username, password, and URL. All I'm doing is assigning those specific pieces, username, password, and URL, to the variables that I've defined as part of my HCL. So that's an argument there.
Nice.
And a block is a series of arguments that are put together, but they're denoted by the curly brackets. And quite honestly, once you get used to looking at the curly brackets, it makes things a lot easier than having the white space indentation with YAML. Because what I found that if you don't, you'll hit tab one too many times, or the white space is too far off, your YAML with Ansible is broken. Because I use those delimiting curly brackets in Terraform, everything that's ensconced within those brackets is part of that, in this case, resource for a tenant for ACI. I don't have to worry about white space. It could be one space, it could be 10 spaces. They could be different between the name and description. It doesn't matter because I've ensconced them in those brackets. So it must be assigned to that resource block that I've highlighted there in red. So it's a little bit, it looks a little bit scary, but once you get used to looking for curly brackets, it's a pretty easy language to navigate and find what's allocated to what. And obviously within modern code editors, VS Code, or even if you're a VI guy like myself, they have, colored brackets so you can see what aligns to what. So you're not missing things. You don't have to go and count each individual bracket.
That's great.
Every HCL plan is of similar structure. So it is possible that the two main items that you'll encounter there's a few of them. The two main configuration-based items that you'll encounter are either data sources, which allows us to read in a configuration, or resources, which send configuration to a given device. So up what I've highlighted in red, this is gathering some information from something. In this case, it's a tenant with inside of the, used to be called multi-site orchestrator. Now it's Nexus Dashboard Orchestrator. But I'm gathering the name of a tenant that's already been created. So I'm gathering that with that data source. And then you can see down below, I have that tenant ID. I then can reference that piece with the data that I've read in. I can reference that later on and reuse it. So I don't have to worry about configuring everything with Terraform. I can read in some configuration and then use that in my plans. The other thing that gets a little bit scary, or people aren't necessarily used to, is the dotted notation for nesting of objects. So what I've kind of done here is, if we follow the green pieces down, we have this resource, and we don't even need to know what that resource is, but it's called MSO schema. That's the name of the configuration item. That second thing, schema object, is a locally significant name that I've assigned to it, because I may create one or more of those same schemas inside of my plan. So I have this MSO schema object. Now, if we go back and we follow it down, we have this inside of that block, we have this template name called template1. So inside of that block, I have MSO schema object, template name. And that's how I would reference that specific item or argument. And that's what we've done in the bottom part where I've got the long green bar. That's how we reference something that we've already created. So we have the name of the resource, we have the locally significant name that we've created, and then the argument that we want to do in there. So we can use that dotted notation to nest and kind of figure out items. It's very similar to like Pythonic methods if we're looking to draw an analogy to a programming language or something like that. So I know it's getting a little bit in the weeds, but that's the biggest thing, the takeaway for a CCNA level. You don't need to know all this. What I'm just showing is examples of what HCL looks like. And if you compare these things to YAML, and I've actually done that in a future slide, that's what we're looking for. It's just, does it look like this weird JSONic type structure, or does it look like YAML? And that's how we know whether it's HCL or YAML. The last thing that I want to do or touch on is it is possible to do programmatic things. And I use that in quotes there. So within Ansible, I know we can do things, loops and structures and things like that. It's possible to do the same thing in Terraform. In this case, I have this variable called switches, and I've defined sets of switches with different IP addresses and roles, and we can iterate over that variable and assign, in this case, the role and IP for that specific iteration.
Nice. Based
on that inventory data model and definition that I've given over there on the right-hand side. So we can do some programmatic things as well. This is probably one of the other takeaway slides. I think there's this one, and then I think there's the next one that'll be probably the most of what you'll need to know for the CCNA. And this is just a comparison between an Ansible configuration and a Terraform configuration. Both are doing the same thing. And unfortunately, again, this is with the ACI stuff, just because I used to work with that when I was in DevNet. And so I became really familiar with those APIs. But you can see the difference of what YAML looks like and what it looks like in HCL. A couple of things I do want to clear up, though. One, people will generally say that Ansible is not a declarative automation language. And I take a little bit of issue with that. It is declarative in as much as each individual task at the task level, I'm using a domain specific language. I'm using the modules that are there with Ansible, and it's doing its thing based on kind of what I'm telling it to do. I'm not telling it how to do it. I'm just saying this is what I want, and go figure it out. And you do it using your modules and things. Now it is procedural in as much as I have to get that order right. So for those, just like we talked about before, I cannot configure an interface with OSPF if I don't have the process running. Yeah. I can't create a trunk if I don't have the encapsulation method set on that interface before I declare a trunk, like those kinds of things. It's the same thing with Ansible. I have to get that very procedural piece. Terraform, I don't have to worry about that. Terraform just figures it out based on the graph that is created as part of the provider and configuration. And then finally, this is just an eye chart of like comparisons between the two. So we have Ansible on one side, Terraform on the other. We have the years they were developed, the base language that they're written in, whether it be Python or Go, the domain-specific language, whether it be YAML or HCL, the connection methods. And this is really the big kicker, like I said earlier. We can use Ansible to connect via SSH. We can do APIs. We can use netconf to send configuration, all because it has that native SSH library underneath it to be able to interact with these things. Terraform is API only. So if it doesn't have a REST API, you cannot use Terraform to automate it. And then the bottom piece there, that primary use case, and this may be a little bit pedantic or splitting hairs, but Ansible is really meant for that configuration management. I have these little bits and items that I've configured. I may want to make sure that they stay in place, or I may want to change like SNMP values or IP addresses or logging servers. And I drift from A to B inside of that. And it does that configuration management and enforcement really, really well. Terraform is meant for, like I said, that scaffolding, the immutable infrastructure provisioning, where I want to set something up and maybe it's a server in the cloud, and I just want to have it stood up with a certain amount of CPU and memory and disk space and a certain security policy. And maybe I want to have that all, I want to duplicate that or whatever. Maybe it's 4 or 5 servers. But what Terraform will not do is say, okay, now that I have that server, I need to make sure that I have certain packages installed. Maybe I want to run an Nginx web server, or I'm running a LAMP stack or whatever. Terraform doesn't really excel in that individual configuration management piece. It'll stand up a server, but then we would generally call some kind of local executor. So whether that be Ansible or Bash script, something else, to do that configuration piece. So it's I guess the net of all that is it's not necessarily one or the other. Both excel in certain items. They can be used together. They could be used as, separately, because Ansible will configure stuff in the cloud. I can provision AWS servers using Ansible if I wanted to. But it doesn't have to be an either or. It's like, do you prefer Terraform or Ansible? Well, if given the choice, I like Terraform just because I've been working with it for so long.
Yeah.
But that doesn't mean that if Terraform doesn't fit, I'm going to find a way to brute force it.
Yeah.
So it doesn't have to be mutually exclusive. You can kind of use them better together if the use case or need arises.
Quinn, is it correct to say that Ansible is great for, say, Cisco routers and switches because we don't have a northbound API, like a REST API necessarily, and then Terraform is great for the cloud because you've got that API. Is that kind of correct or not?
Yeah, I mean, at a foundational level, yes. Terraform will not work with routers and switches. You're going to be using Ansible for that automation. If you have a controller, like, say someone has moved on from their CCNA and they're looking to do their data center studies, and they start playing around with building like Nexus fabrics, VXLAN EVPN fabrics, and they're using Nexus Dashboard Fabric Controller to do that, you can use Terraform to configure the controller, which will then configure those switches. But if we're going device by device, then yes, your Ansible will be the tool of your choice. And then whether it's configuration network controllers or it's the cloud, I generally will use Terraform to provision the infrastructure, and I may use something like Ansible over the top to do the configuration bits inside of that. But yeah, that's a good delineation. If you're doing routers and switches with SSH, you're using Ansible.
Yeah, I'm glad you mentioned it right in the beginning, SSH. So that's a big reason, right? So Quinn, this is fantastic. I got some more questions for you. You mentioned Ansible drift. I'm not sure what that means. And then you also mentioned like immutable. Could you explain, like, is it mutable, immutable, and Ansible drift? Like, what does that mean?
Yeah, they all kind of go together. And when I use Ansible drift, like I use Ansible does drift fairly well. Meaning, say I've got like a administrative like break glass passwords, or I've got SNMP communities or keys or something like that. Ansible, because of how it's built, can say, I want to remove and take this configuration out that already exists and then replace it with something new. And it does that drift that it doesn't have to recreate the entire configuration on that router or switch. It just says, I'm going to take this little tiny piece of it and replace it with something else. So that when I use drift, that's really what I mean. And that drift means natively that's mutable infrastructure. If you think of like the difference of soft clay versus something that you've already fired, right? Like, if it's mutable infrastructure, I can mold and shape and do what I want, take pieces away or put pieces on there, move it around. And Ansible does that really well. I can create and play with my infrastructure and move it and drift it and manage it in a certain way. Terraform is like I buy a vase, right? I buy a vase that someone's already put the work into. And if I don't like that vase, I have to put it aside and go buy a new one. I can't change what is already there. So that's the immutable piece of it. Terraform really provisions the infrastructure. It sets it up. But to change it, like if I was to go to AWS and say, I want maybe 75 gigs of hard disk, and I say, I want to come back later on and say, I need to change that to 100 gig. It's going to destroy that instance with 75 gigs of hard disk space and then replace it with a 100 gig instance. So it's not going to say, we're just going to make that hard drive bigger. We're going to rip out and replace it. So hopefully that kind of analogy works or resonates.
I was going to say that's a brilliant analogy. I like that. So it's soft clay versus like something that's already been baked in fire. I love it. So as I would say, a vase that you have to destroy it basically and then get a new one.
Exactly.
Yes. And that's immutable, right?
Mm-hmm. So, like I said, between last slide and this slide are really, and so familiar with the HCL, if you know those things, then you're really set for the CCNA. Like, we're not asking you to build certain things. We just have to identify. And I didn't touch on this a whole lot, but if you go back to that exam blueprint, each of those verbs or the tasks, I should say, have a verb in them. Explain, identify, maybe compare, configure, troubleshoot. We use what's called Bloom's taxonomy, and that is a hierarchical way of saying the level of knowledge that you should know. So things like identify or describe are kind of that low level. Compare means I have to do two identifies and see how they vary. And then obviously configure is something I have to do hands on keyboard, and troubleshooting means not only do I have to understand how to configure it, but how it breaks. So if we go back to that exam topic for, Terraform and Ansible, we just had to be able to identify and compare. So we're not looking for that real deep technical knowledge. We just need to know the differences, what they look like, and be able to compare and contrast them. And that between the last slide and this slide really encapsulate a lot of that knowledge, and just be able to look at HCL and say, yep, I know that comes from a Terraform plan. You're in good shape. We've talked about what Terraform is, the workflow, what the configuration files looks like. Now let's actually put it into practice. So what I'd like to do now is kind of jump over to my demonstration screen here. And this is just a Visual Studio Code for a demo that I've done in Cisco Live's past. So I mentioned that when I do these demonstrations, and I need to use cloud resources, I will use Terraform in order to instantiate those cloud resources so that A, I know that they're going to be available the day that I need them, and B, to make sure that when I'm done with them, I can destroy them, so I don't have to explain, a several $1,000 AWS bill to my management. Kind of avoiding those resume generating events is kind of my number one priority here.
Yeah, exactly.
So what I have here is something that we'll move this down a little bit. Over here in this Terraform folder, we see a couple of different .tf files. We have a main, an outputs, a providers, this Terraform.tf vars, and then variables.tf. I will not be showing you the Terraform TF vars because that includes all of my AWS passkey information. I'd rather not have to go through and rotate my keys, but I'll show you everything else. So,
Quinn, do you mind just showing us that file? I know you don't want your personal stuff shown, but we'll just blur it in the video.
For you, David, since you asked nicely, yes, absolutely.
Appreciate it.
So this is the Terraform.tfr. So I have the AWS secret, access key and the secret key. So those are like your API keys to access your account. And then the other piece of it is making sure you have your appropriate SSH key name. So whatever you've named your SSH key pair that you've downloaded from your EC2 control panel inside of AWS, and then the location of that. So a couple of things, and I have instructions here. If you're a Windows user, you have to, and all this is available on my GitHub, in the repo, but you've got to do double backslashes if you're in Windows. The other important piece of it is because it's an SSH key, you have to have 400 permissions. So that's basically, just read and, that's just read, for your own local user. No one else should be able to access it. So kind of a security thing. So if you're having trouble, if you download your SSH key and you run, it'll say, hey, we can't use this key because permissions are too wide. Then you just need to make sure you go back and change your permissions on that SSH key so that only your user can read it. And then you'll be in business.
That's great. And I mean, I'm assuming you're not using your real credentials on GitHub, right?
No. This is all obscured as well. I'm not going to, going back to that, avoiding those resume generating events. I'm pretty sure that would be a big one.
So, I mean, for everyone who's watching, they would have to obviously put in their keys then. So if you just scroll to the top, it's those two entries that have to be updated, right?
Yes.
Yeah.
Yes, great. Absolutely. Well, all four of them will. You'll need to update the key path, the key pair name, as well as the keys. But those keys are the big credentials there. We'll start off with the providers here. And this is, just a Terraform configuration that says we're going to be using this provider. In this case, I'm talking to AWS, and we need to have some different pieces in order to connect to that AWS infrastructure. So I need to have my access key and my secret keys, those API keys that I would generate inside of the AWS control panel. So I do need to use the the ClickOps for a little bit to get those keys out. But once I'm done with that, then I can do the whole thing inside of Terraform. And then I have to set what region I'm going to be looking at. In this case, my region is set, and we'll see that in the variables file. I'm using US West 2, but I will change that. If I'm in Amsterdam, I'll use something in the EU. If I'm in Melbourne, I'll use something in APJC, just so I have better response times. I've made the mistake one time of working in Amsterdam and having the region set for APJC, and let's say the experience wasn't great. So we can just change the region there. Next piece here is my variables. So you can see I've defined some things called access keys. I'm going to pull, as well as a private key path. So the SSH key in order to connect to my EC2 instance, the name of that key. And then, like I said, here's the region that I've set for that US West 1, which is Northern California inside of the AWS. So nothing really fancy going on here. This is just kind of setting up the basic infrastructure or the basic pieces to connect to AWS and some variables. The real magic happens here in this main.tf. And generally, this main.tf file is where you'll have a lot of the different actual configuration items for a small Terraform project. One thing I didn't really note here is Terraform. You'll see a lot of these files, and you'll see in the workflow. We can think of a folder as an individual project. So I have this folder called Terraform that I'm operating in with these different files. When I do a Terraform plan or Terraform apply, I won't need to tell Terraform which files to look at. It just says, oh, all of these are HCL. All of these are Terraform compliant. I'm going to mash them all up, run my dependency map graph, and then spit at the output and configure the infrastructure the way it's needed. So that's why I can separate all these files into different things. I know that if something is going to be changing my provider, I can change it there. I know if I need to change my region, I'll do it in variables.tf. My outputs, and I'll touch on those a little bit. If I want some different data out, I'll show that. Or I can change those things. I don't need to worry about scrolling through these large lines. In this case, I don't think this main.tf is too large, but I've created some several hundred line Terraform plans, and scrolling through that can be kind of a bit obnoxious if you don't separate it. So when I say Terraform project, it's just a folder that has all the Terraform files in it. So in this case, I'm doing one thing. I'm gathering. I want to run an Ubuntu image, so I'm using that data source that's going to look at the AMIs within AWS, and I'm going to be looking for the canonical owner ID, and I'm filtering based on a couple of different things. In this case, it's Ubuntu 2004, and that it supports a certain virtualization type. So these are just filters that are there. So I'm gathering which AMI for Ubuntu is found out of that, and it's going to store that as a variable that I'll then use further on down in my Terraform plan. For resources, not too much here. I'm just going to be using the default VPC to run my EC2 instance in. I'm going to be running, I'm going to create the security group to allow my Kubernetes. In this case, it would be using Kind, which is a Kubernetes and Docker. Not important, but I want to discern that from different security groups that may be running inside of my infrastructure. I'm allowing some certain things like SSH from my local machine. I'm allowing port 8080, 8081, and then 6443. So that's the Kubernetes port. So I'm creating some security policies that say all these things are allowed into my EC2 instance, and then allowing everything outbound from that same instance. So I've created my security policy. Now, this second resource is this AWS instance. So that's the EC2 instance that I want to be running. So in this case, I've used that information from that Ubuntu Linux image, the AMI. So it's finding the ID value of that from that data source that I used above. I'm using a C5A 8x large, so a really big instance inside of AWS there, which again is why I want to make sure I can not only stand it up, but destroy it very quickly, because that's a several $100 a month mistake if I leave it running. And then I reference those security group ID, the ID of the security group that I created above. So that's where I can create that nesting. So you see how within Terraform, I've gathered some information, I've created a security group, and now I'm going to tie all of that together inside of this AWS instance. And I have the dependence on that security group ID being found. I have the dependence on that data for the Ubuntu Linux AMI ID. So you can see how even without knowing how Terraform is doing this under the hood, you can see these linkages. And so Terraform says, oh, I see these in different pieces and different locations. I know that I have to create those two things and gather their ID before I can create that EC2 instance. So I'm not having to worry about, and if I wanted to, I could move this resource up to the very top and the plan would still run. But it knows, because I have these linkages here, what needs to be created before other things.
That's just the intelligence of the product, right?
Yes. Yeah. That's all built into how Terraform builds with the dependency map graph. So I wanted to have some external storage. So 75 gigs of GP2 storage. I'm going to create an SSH connection to the EC2 instance. And this is why. So when I mentioned earlier about configuration management versus kind of the infrastructure provisioning, you see here where I've created the shell, if you will, of this EC2 server. But I haven't told it what packages it needs to install, how it needs to work, where things need to be located. Terraform doesn't really natively do that very well. And so I've created this provisioner. So there's a couple of things here. I have this prereq setup.shell, and I have this gzip of some files that need to be moved up there. And so I'm moving those two things up into the server. So I'm creating basically SCPing those up into the server. And then I'm going to call this remote exec file, which is going to say, now that you have this information up there, you're going to need to run these commands. In this case, it's just some bash commands where I'm doing a decompression of the gzip. I'm changing the properties of the shell script to be executable, and then I'm running that shell script. That is how we can use. So in this case, I've used bash just because I'm a neckbeard and I've an old Linux guy. So I feel real comfortable with bash, but we could do the same thing with Ansible. We could do the same thing with other configuration management tools that we wanted to, because Terraform doesn't naturally work well with those things. So we have to call other tools in order to do that. And so once basically that is at the very end. So we're going to be running that shell script, and I'll just show it here for completeness. It's nothing exciting. I'm doing some apt-get stuff. I'm installing Docker, doing some user mod stuff for the Docker pieces, installing some Terraform, and then kubectl, kind, and caddy, and K9s, which are some tools that I use to do this Kubernetes demo. And then changing some stuff in the file system to support kind of the larger and weird things that kind does when I run Kubernetes and Docker. So it's just a real simple shell script. I could have done this using an Ansible playbook, but like I said, I like bash. And the final piece here is this outputs. So when we have these outputs, we can have Terraform at the end of our configuration application. We can have Terraform put stuff out onto our screen. So in this case, it's going to say, here's how you SSH to this server after we've configured it. Or I can, in case I close that shell window, I can write a file that has the same information to it. So I can go back into this project and say, oh yeah, I've closed that terminal window, but here's how I get to that server if I want to. So that's really it. We have the main, the outputs, the provider, and the variables.
I got to ask you a question because I know a lot of people are going to be asking this or thinking this.
Yeah.
Do you have this code somewhere on GitHub or somewhere where we can download it?
I do. I can give you the link, but it is on my GitHub because one of the things that I have learned is it's great to talk about code, but if people can't play with it after the fact, it really does no value. So it is on my personal GitHub under a CiscoU session. So don't let that description scare you that it was like CiscoU 2010 or something. It is the code for all of this. I'm just repurposing it for this demonstration.
So for everyone who's watching, I'll put the links below so you can go and get the code. But Quinn, I've got to ask you this while we're talking about links. Can people follow you on LinkedIn, or where's a good place to get hold of you? So I'll put those links below as well. Yeah,
so you can find me on LinkedIn, linkedin.com/in/QSnyder. I'm also available on, I guess it's X, I still call it Twitter, at QSnyder as well. You can reach out to me. Probably those two places are the best, and I can get you the information that you need, or talk about this or any other Terraform related stuff that is on your mind.
So for everyone who's watching, that's a huge benefit. Please go and show the love. Connect to Quinn, but don't send him a million questions, but hopefully you'll be able to connect and help you with some of your questions, and use the link below to get the code. Sorry to interrupt you, Quinn, but I think that's a great benefit for people who are watching.
Yeah, absolutely. I love work, interacting with the computer. I wouldn't be in advocacy if I didn't like answering questions and education and helping people. So definitely a great benefit. And I'm also at pretty much every Cisco Live, usually in the CiscoU, the learning and certifications area. So you can find me there as well. So one of the things I didn't necessarily touch, so in order to get this rolling, and one of the things I didn't touch on in the in that workflow window or workflow circle earlier was the Terraform init. So in order for, we've defined our provider, we've given it some information, some keys and things like that, but Terraform doesn't know how to connect to AWS, just as I have some information. So what we have to do beforehand is do a Terraform, if I can type init. And what this does is it reaches out to, in this case, HashiCorp, the registry, to download the provider in order to allow us to connect to AWS. So it's going out, it's finding a certain version. We can do version pinning. If we're using something like a Cisco provided one for, say, ACI, it may look different. It may not reach out to HashiCorp. It's going to reach out to the Cisco DevNet GitHub repo, but it's going to download and install that provider, which gives us that foundation. It gives us the back end knowledge of what things need to be configured in what order, and then it will also allow us to connect to AWS. And I know my window's a little bit big here. Ordinarily, I just want to point out that if you were to run this code, configure it, whatever, by default, it would look green on the stuff that's blue would look green for accessibility pieces. And I want to make sure that people who necessarily can't see color kind of see the differences. So it's blue in mine. But what this is saying is we have this signed. So because it's coming from HashiCorp, we know that we're getting the right provider. It's signed. We're not having any man in the middle things. If you're looking at a third party provider, you'll see a key ID that's validated. So the keys are embedded in the provider and they're checked against the HashiCorp registry to make sure that you're not, leaking credentials. Because like I said, I've got credentials that talk to my AWS account here. So if you have some kind of man in the middle kind of compromise, could be a big financial risk. So It does verify that all these are signed and valid. So with that, the next step is to do a Terraform plan. And what I'm going to do here is do an out.tf plan. This is kind of a good best practice because Terraform, if I invoke Terraform plan without an out file, it'll just say that, it's basically checking moment in time, right? So if someone were to come in and change my Terraform plan before I did an apply, I may not be able to guarantee the same pieces. So what this out file tf.plan will do is say, here's the snapshot of the plan as we ran it. And if I apply that, I can guarantee that it's going to, the output will be the same every time. So I'll do this Terraform out tf plan. I don't have any state right now inside of my project folder. So it's going to say, I'm going to reach out. I don't have any state. So it's going to find the information. Like I said, that Ubuntu Linux AMI, it's going to reach out and try to say, okay, what needs to change? What do we need to add? And again, these blue pluses will normally be green if you were to run this without having the accessibility stuff turned on. But you can see that I've gone through and I've found, there's a lot here. I have found it's going to create the VPC. First of all, it found the AMI for the Ubuntu Linux version that I want. Everything that here is going to be a create. If I had to destroy stuff, you'll see a minus. If it changes, it'll be a tilde. It's going to create a VPC. It's going to create an EC2 instance. And some of these things that are known after apply are just configuration items that I could add in there if I wanted to. But I don't necessarily care. Anything that has a value there is something that I've defined as part of my plans. In this case, like the instance type being the really big C5A 8x large. Some things it's pulled from variables. So like my key name is QMS EC2 key pair. That's the SSH keys that I use to connect. It's going to create the security tags and all that kind of stuff. Here's the storage, security group, and then at the very bottom here, you can see it's going to have some outputs here. So it's going to output the SSH command and the address of the EC2 instance that it'll create to my screen. So it saved it to this tf.plan. And what I mentioned earlier here is I can apply that TF plan. So say, for example, and I know I didn't do a very good job of explaining this earlier. Right now I have a 75 gig hard disk and I want to apply a 75 gig hard disk to my instance. If someone were to come in, say I was using a multi-user environment, or maybe I'm collaborating on GitHub, and someone changes that to 100 gig and I do a Terraform apply, well, it doesn't, the plan and apply are two different actions. The plan is like, kind of, here's what's going to happen when you do this. Are you sure you want to do it? The apply says we're going to make that change. So it's like a built-in two-stage commit process. So apply and plan are disconnected. Now, since I've saved my plan to an out file, if I do Terraform apply TF plan, I've linked those two together. So whatever was here when I ran that Terraform plan will now be applied in that apply action, if that makes sense.
Yeah.
So now let me just clear that. So I have a little bit of space here. I'm going to apply this plan. And this is where the magic is happening. So it's going to take a little bit because of all the things that it has to do. So I don't know if you've heard the term cloud patience, but it's going to go through. It's going to reach out using the AWS APIs. It's going to do that same stuff it did before. It's going to gather that AMI. It's going to create the default VPC. It's going to create that security group, and then it's going to create this EC2 instance. So you kind of get a rough timeline. It took 2 seconds for this, 2 seconds for this. The EC2 instance is going to take a little bit longer. In this case, it's still creating. It's going to try to provision, and then it'll kind of roll through. Every cloud provider is different. So in this case, AWS, I think it takes, so we're already up and running. It's now running that script. It's doing all of the apt-get stuff. If we're working in different cloud providers, that provisioning may have taken a little bit longer. Different device types. So I've used this to build like VPNs inside of Azure. The network VPN concentrator aspect of Azure takes up to like 30 minutes to build. So sometimes it takes a little bit longer. But you can see we've gone through, we're doing that remote exec now. So it's running that bash script. It's setting up all those pieces with the apt-get and update. It's got those files copied over. It's you can see it's updating the kernel image. And eventually what you'll see is it's at the very end, it'll roll through and connect everything and make sure that everything's provisioned. And we'll have the output of the SSH command at the very bottom of the window here. So it's completed, and you can see based on those outputs that we had here, a couple of things have changed, or a couple of things have been generated in the bottom of the shell here. So first of all, this is the address of the EC2 instance that I created, and then because I'm lazy and because I have a lot of different key pairs for a lot of different regions, I don't want to remember which one I've used. So I've kind of created this manual SSH command thing. So this is just the output that I could pull out of AWS, out of Terraform by running it. But I've added some information here. So if I wanted to SSH directly to that server, I can just, copy in between the individual quote marks here. And I can do a copy. I won't do a clear here. And I can do a paste. And we're now in this Ubuntu,
nice.
IP whatever. And you can see, if I was to do an LL here, you can see that CiscoU 2001 tar GZ is there. If I was to run something like K9S, which is something that I installed there. K9S. You can see we're K9S there. We can quit. We have Docker. So we have Docker installed. So all those different things that I told it to provision with that shell script are there inside that server based on what I've defined.
So yeah, Quinn, we don't believe you. So do a uname. Okay, great. So we can see running Linux there, Ubuntu. So if you exit, what do you get when you do uname on your local system?
Nothing up my sleeve. Old Rocky and Bullwinkle joke. So if I do a uname, you can see we're in Darwin there. So nothing has changed. Or we've moved between the two. There's nothing up the sleeve there. And then the other thing I want to point out is because I had that file output that I mentioned, so we had that stuff that was displayed in the bottom of the terminal. I also have the file here, which gives me the same command. So if I was to clear this, I have that. So
that's just something you added to your like script, if you like, whatever you call it, right?
Yeah. The outputs.tf here is what I've done. So I've done the local file to put that IP address out there, as well as the output, which output naturally directs it to the shell. Output file directs it to a file in the folder. So like I said, what I'm going to do is I'm going to copy this just to show you that there is nothing up my sleeve when it comes to the destroy action. So what I'm going to do here is I'm going to do Terraform plan. I'm just going to do a Terraform destroy, and I'm going to do an auto approve. So what this says is I won't do the auto approve just to show you that this is Terraform tries to make it safe for you. So if I do Terraform destroy, it's going to go through and say, we've looked at the state. So over here on the side, we can see this terraform.tf state. It's tracked the state. It knows that it has configured these servers. It's checking to make sure that the state of those servers exists and compare it to what the Terraform configuration is to make sure that everything is still in line. Because if it's not in line, if things have drifted, Terraform says, I can't manage this anymore because my state and your configuration file are no longer consistent. I'm going to abort. I can't destroy stuff that I don't know about. So you can see here all the different changes. It's gone from the pluses and now it's all the minuses. Those yellow minuses, those would normally be red. But at the very bottom here, it says, are you sure you want to do this? There's no undoing it. You can't just say, oops, cancel, I'm done. So it prompts you for a yes or no. If I was to type no, it would go back to the shell. If I type yes, it will delete. That last flag, that Terraform destroy -auto approve, that would skip this process. This says I'm living dangerously. I know what I'm doing. Don't prompt me. I don't have to click yes, whatever. So I'm going to type yes here, and it's going to go through. And the destruction is much faster than the creation. So you can see that it's removed that file because that was part of the outputs. It's going to start destroying all the infrastructure, so that EC2 instance, removing the security groups, removing the VPCs, all of that was defined inside of that Terraform plan is going to be removed from my infrastructure. And when this is all complete, I'll show you by trying to access that same infrastructure using that SSH command that I used earlier, and I'll show you that it will fail.
What happens if you install software? So like you got that thing to like use bash to install software, the EC2 instance. What happens if you installed extra software? Would Terraform fail then when you try to destroy it?
No, because it's not tracking that, right?
Okay.
So Terraform, the Terraform.tf state, and you can manage these things here, and you can see there's things that it's tracking. There's things that it knows about. There, based on those resource applications and things like that. When I've called those local or remote executors, it doesn't really know about that. It just says, I'm going to call this. It's kind of like an ephemeral action. Just do this, but I'm not tracking that state. So I can manage and change that state around. In fact, the way that I developed all of this, that bash script, was building an EC2 instance and then basically echoing all of my shell commands that I had to type to get it to work, and piping it to T and then redirecting it to an output file. And then I had that whole output file. I just copied and pasted that into my shell script. So kind of brute forced it that way, but it wasn't tracking any of those things. I could still destroy it after I install all that software because it didn't hold on to that as part of the state. If it's not natively part of Terraform, it's not tracking it.
Well, that's great. If you went into the UI on Amazon and then changed something like the disk size, or I don't know, something that you can change, then it would fail, right?
Then it would fail, yes.
Yeah.
And in certain, I know that we do this with ACI. Certain cloud providers are also trying to adopt this, that the orchestrator, that they get tagged by default. When you use Terraform to configure it, it'll tag it with Terraform to say, basically as a warning sign, like, hey, don't touch this because if you change something, it may break someone else's Terraform routine.
Nice.
So here's that SSH command that we used earlier. I'll just hit enter. You can see it's going to fail because I actually have indeed, again, nothing up my sleeve, that we have destroyed that EC2 instance up in the cloud. So I don't have to worry about, that several $100 cloud bill coming due at the end of the month.
This is brilliant. Thanks so much, man. This is a great demo.
Appreciate it. Thank you. So with all this, like I said, we've gone through kind of the CCNA, requisite knowledge. Again, it's not intimidating. It's something that just a little bit of refresh and study, you'll feel comfortable with. But like I said, I wanted to make it a little bit realistic, and kind of show you how to use Terraform, at least in a cloud instance. We have several tutorials around Terraform on CiscoU, which is our learning platform. Our tutorials, if you're not aware, you can go to u.cisco.com, create a free account, and have access to all of our tutorials, which are kind of our bite-sized moment of learning. I equate it to like a recipe that you'd find online. I don't need to know the whole backstory. Just give me the instructions on how to cook a roast so I don't disappoint my family on Sunday. Those kinds of things. So very quick instructions on how to accomplish a certain thing. We have those for Terraform. We have them for using Terraform with ACI, just kind of a primer. So, through all this, I know we kind of divided up into two different parts here. So at the top, we talked about kind of the knowledge that we need to know for the CCNA, and hopefully that wasn't too intimidating. But we also did this hands-on piece and the demonstration to show you how we actually put that into practice. For those who are curious about actually doing it themselves, obviously there's a code for this on GitHub, but we also have free tutorials within CiscoU. So CiscoU is our learning platform. Our tutorials, which are things that me and my team help create, are what we call moment of need learning. So very bite-sized 20 to 45 minute exercises that focus on a specific topic. I like to use the analogy of a recipe. I don't need to know all of the different backstories of how this, recipe is significant or why it's historically important. I just need to know what I need and how to cook it. And that's kind of what we focus with our tutorials. It's here's what you're going to learn, here's what you need, and here's how you do it. So we have tutorials, and I'll provide links to all those on Terraform. So how to use Terraform, using Terraform both on-prem as well as in the cloud. I've got some presentation or some tutorials that I wrote actually for an event we had earlier this year around how to use how to reverse engineer Terraform. So there's a couple of tools out there to actually take ClickOps configuration and convert that back into Terraform configurations. So even if you're just using ClickOps, you can still extract some configuration and realize and learn how to use the different provider pieces. So that's a really cool tutorial as well. Again, it's u.cisco.com. It's free. You just need to create an account that's tied to a CCO. But again, you can create a free CCO and you can create a free account. You'll have access to all of those tutorials. We have some on Terraform and other automation. We have them on CCNA and CCNA level topics. We've had over 100 tutorials so far, and it's growing pretty much every month.
That's fantastic. I mean, I'm so glad that Cisco are making more and more stuff freely available. So just to confirm, the tutorials are free, right?
Yes, the tutorials are perpetually free. So you'll be able to access those and learn by doing. You may need to provide your own infrastructure. A lot of times we try to use, especially now with the new CML 2.8 release, this is Modeling Labs 2.8 free tier. We have a lot of things that can run in that free tier. We do things through other sandboxes that are freely available. So we try to make it as accessible as possible for as many people as possible, because we know, again, time is short, money can be short, and we want to make sure that everyone has a chance to learn as much as possible.
That's brilliant. Quinn, before we wrap up, where can people reach you? Just again, can you give us your links? Tell us, where the best places are, and if people have got questions, can they ask you those?
Yeah. The best places. I'm usually on Twitter, X now, at Q Snyder, so QSNYDER. Same thing for LinkedIn. It's linkedin.com/in/Q Snyder. Those are good places to reach out, connect, message, ask questions. I'm also available. We have our virtual events. We have that we do, CiscoU Spotlight. I am at every Cisco Live at the learning and certifications area. So if you happen to have a chance to visit us in the hub areas, usually I'm there working the booth or giving presentations. So I'm more than happy to answer whatever questions, comments that you have via any of those channels. I love meeting and interacting with people, and so whether it's virtually or in person, I'm here.
We've got to get you back for perhaps Ansible. So for everyone who's watching, please put your comments below. Let us know the kind of stuff that you want Quinn to cover. But Quinn, you could come and do Ansible and perhaps some other topics as well, right?
Yeah, Ansible is one. I could talk high-level automation. So like I said, I was in DevNet for a few years.
Yeah.
And actually, even before this, I was a network engineer. So I spent about over a decade at a partner. Data center type stuff, routing and switching stuff, like all of that it's all things that are very near and dear to my heart. I just happen to do a lot more automation now in my day-to-day job than anything else.
Yeah. So again, for everyone who's watching, put your comments below, the kind of stuff that you want Quinn to cover. Really want to thank Cisco once again for sponsoring this video and making experts like Quinn available for all of us to learn from. Quinn, again, thanks so much.
No, thank you for having me, David. Really appreciate it.